Hello everyone, this is Mukundan Raghavan. In previous videos, we have seen how to make two agents to interact with each other. Whereas in this video, we are going to implement the code executors. Unlike previous video, we are going to make one agent to execute the code which is generated by the other agent. And this is where the goal-oriented agentic framework starts. It's not about only creating the code, but also executing the code. However, it is only for development and testing perspective. And also we should be very careful while using the code which is generated by the LLM. And here we have three methods to execute the code generated by the LLM in local, in Docker container, in Jupyter kernel. As part of this video, we are going to see the local execution. Now with this, we will try to see the scenario which we are going to plan now. The scenario is you will be asked with Python interview questions, and this Python interview questions will be given to the code executor agent. This code executor agent at that point of time will not have any code. So it will be asking the another agent, which is code writer agent. This code writer agent will create the code, save it into the local, then it will execute in the command line by giving to the code executor agent. So basically here there are two agents, code writer and code executor. So with this, we will try to understand the code for the demo purpose. Here, the first one, it starts from the main config list. Obviously, we are getting the LLM config, which is Llama in our case. Then we are creating the code writer agent. When you go for the code writer agent, so we are giving the well-defined system message for the code writer, how it should behave, and what are the things it has to generate, what are the things it has to analyze and debug and give the clear output of Python program. Then also we are telling code execution config as false so that it will not execute directly because its job is only to write the code. So it will write the code and give back to us. Now the second one, code executor agent. So this is where we are going to execute the code and this agent is responsible to execute the code. Since its job is only to execute, there is no LLM required for this code executor agent. And also we need to give the configuration for the code execution. Why? Because we have three different ways, Docker, local, and Jupyter. In order to execute in local, you need to create the executor instance. That's why here you are creating the local command line code executor. And for this, we are giving the timeout as well as the working directory. Working directory you can directly get from the current directory is equal to os dot get current working directory. Or even you can look for the temporary directory by using the temp file dot temporary directory. In temporary directory, after executing, you need to clean up. As the name suggests, it will be a temporary purpose. In our use case, we are preparing for the interview so that we give the program to be created and to be executed. After executing, the working code will be saved into the local. Now here we have mentioned human input is always. That means that every stage of LLM outputs between the conversation of code writer agent and code executor agent, you will be having the option to interrupt or to stop the execution. Now the last one is start conversation. So in the start conversation, you are going to give the code writer agent and code executor agent. Now here again it starts code executor agent initiate the chart to the code writer agent. And it is telling I need to write a Python code to calculate the sum of 10 prime numbers. Maybe it could be the first 10 prime numbers. Then after executing this, it will be giving the chat result. However, we will try to see here how the conversation goes and how it creates the output. First code executor is asking the code writer agent, write a Python code to calculate the sum of first 10 prime numbers. and it is generating the output, and example also it's giving. Now here we have the option to see the code quality and any kind of issues. If everything looks good, you can just click on enter. Now code executor agent, it is replying to the code writer agent. I have executed the code, exit code is 0. Code output, the sum of the first 10 prime numbers is 129. Again, code writer agent to the code executor agent. It is giving the justification how it is being calculated. Then finally, everything looks good. And also, we are saving this file into the local. Let's see. Maybe we can press enter. Okay, this conversation, since there are no further question tasks, okay, conversation is completed. Now just type exit. Now we have completed. Now let's go to the output and see. So prime sum, and here you can see the file, which is working fine, and we have saved the file also. So like this, we can create a lot of Python interview questions, and we can see the output, we can execute and check it. So this is a simple example how agents can execute the code, not only interacting with each other, but also executes the code. So in this conversation, you have seen there are two agents, code writer agent, code executor agent. Code executor agent will start the conversation by asking the question, I need some kind of program. And code writer will create the code and give back to the code executor. And code executor will execute the code and give back to the code writer. And it will try to see the justification, whether the program works fine or not. By the time you can close the conversation, since you are having the full intervention capability in middle of any kind of steps. Then you will exit the code, you will exit the conversation, then the file will be saved. So this is a simple way how we can make one agent to execute the code. And this is all about this video, and always be a rainbow in others' cloud.